Hello everyone, so today I will be working on the tree rendering system that I have implemented lately in the NervLand engine. We have a quick demonstration here of what those trees are currently looking like, and it's a pretty complex mechanism in fact, so I'm going to provide some details on how this is actually implemented. And for the rendering, we are using currently 3 different layers of different resolution, if you want. So we have a HD layer, a medium definition layer, and a low definition layer. Currently this is applied only on the trunks here, so if you see the trunks are kind of orange yellow like this, it means this is the medium layer. For the trees that are very far away, we basically don't see that here, but the trunks are rendered in red currently, and if you go very close you get everything in blue. So that's where you get maximum definition for every single tree, and otherwise you get a lower resolution here. And if you go further, you see that some of them start getting red. So yeah, that's lowest resolution that we have. So I want to make this as a kind of devlog recording this time. So we'll be working on adding some specific feature. And the first thing I would like to start with is a small correction on one feature that I have, which is allowing me to look at some location, for instance like this, and if I use Shift T, it's just going to put some trees randomly somewhere visible in the current frustrum. So the mechanism to achieve this is currently as follows. We have the ground location here in black, and you have the view frustrum depicted in red currently, and you're just going to select a few random direction pointing from the current camera position, and you will figure out what is the elevation or at least the depth value compared to the camera for the corresponding point which is rendered on screen. Once you have this depth information, you can recompute the location of this point first in the camera space, and then you can convert that into the world space. And with the world position on the ground, you have a proper location to add a new tree. So we're just going to sample the depth buffer like this and get a computation for the world position at a different point. But one issue that I have is that I'm not dealing with a case where maybe the camera is looking a bit up. So if we are in this configuration, for instance, and you're considering this random direction for your sampling, then you're not going to get any intersection with the ground, which means the depth value would be 1. And in this case, we don't want to render any tree. We're just going to discard this iteration and continue with the other direction. So let's make the corresponding change now. So in the code, this is the function I'm currently using to place those random trees in the current frustrum. And we're just going to iterate on the number of trees that we want to add. For each of them, we generate a random clip coordinate. And this clip coordinate is what we use to retrieve the camera direction by unprojecting those coordinates with the projection inverse matrix. And then we see that this is where we do the sampling from the depth texture. So we just retrieve the pixel value corresponding to those clip coordinates, and the reading is done here. So we get the log depth value at this point. And this one is the one that could be 1. So if it's 1, we're just going to stop here. Okay, so, and now let's run this again. So if I go in a position like this one, for instance, and I try to place some trees, many location would be just in the sky, so there should be no tree added for those samples. except that I'm not really providing any feedback, so that's going to be a problem. Let's get back to the code. Let's add a line here specifying that we're just discarding this tree location. And let's also keep a count of the valid location. So now trying again with a large part of sky in the view. And if I use Shift T, it's telling me that it's adding 5 trees on the ground, while in fact the number of trees that can be placed should be 10. So we should also have indication that some of the requests were discarded, ignoring tree placement 5 or 6, 0 or 1, and so on. So this works, and now if I keep pressing Shift T, it's just going to add more trees, but only in the, in the valid part. This is an interesting thing. This flickering here, why do we have that? And it's even disappearing in some cases. Okay, another bug that I will need to investigate. So I have now just added this section on my note page for this issue, and just indicating that we have updated the code as we just did. So the next thing I would like to deal with now is the case where we are looking at ocean surface, for instance, in the frustum, because currently there's no specific handling for this case, and if I try to place some trees looking at this view, for instance, there are chances that some trees will be added under the sea level on the ground that we see below the sea. So I don't really want this, and I would like to just discard the tree in this case also. So how are we going to do this? Let's just think about it for a moment. So if we consider the case like here where we're just starting with the camera location, and we have computed a world position which is in fact under the sea level. The thing is, this world position is a position value given in world coordinates, so starting from the center of the Earth. So you have the center of the Earth somewhere here, and that's a description that we have for this point. Okay, if we have this, we can in fact figure out what is the altitude of this point above the sea level or under the sea level. We just need to know what is the convention used for the sea level height value, and then we can just say that if the corresponding altitude is below this level, then we're just discarding this point. So let's do that. So now the question is, what is the reference sea level value that we are using in NervLand? I kind of remember that we have the Earth radius, which is made to correspond to the absolute bottom that you can have under the sea for the ground, which means that the sea level itself is in fact a bit above that. Where do we do that? Okay, so I think I found the location where we are setting this up, and this is when I'm building the main scene, in fact, and preparing for the construction of the planet object. And we see that here we're using this bottom radius of the atmosphere as reference sea level radius. Okay, and then we're just doing something to in fact modify the radius that we would use for the planet rendering itself to ensure that this sea level will not be changed. So the sea level should really be at this radius value, I think. So what we just computed before as sea level is in fact a normalized sea level value, so it should be between 0 and 1, and then we would use the elevation scale to figure out what is the value we should use in meters. So that should be how we compute the sea level elevation altitude above the ground in meters. And so now back to the placement of the trees. We need to compare this land value to the planet, which means we should also retrieve this information here. So do we have the planet at this point? Yes, we have it here, and we can just retrieve the sea level value and also pass that to the lambda which is created, and finally give it to the function to do the construction. Oh, I mean that should be before, okay? Yes, it's before the log_def context. So now we can use that to do the comparison here, which also means that we cannot increase the count just at this point, but we should do that afterwards. Okay, so now rebuilding, and let's now try to place some trees just in the middle of the ocean, and in theory we should not be able to place anything. Location is under sea level, great. And if we have a partial view on the ocean like this, we might be able to place a few trees anyway. That is weird. Okay, so we have a problem. Every location is considered under the sea level. Not quite what I expected. So let's try to figure out what is going wrong. First, let's add some debugging to display what is the actual value that we have for this comparison. And this is a kind of output that we get. And this is interesting because in fact I would expect the sea level to be really what we use as default Earth radius for this is what we use for the atmosphere here. So this bottom radius here, it's coming from the atmosphere model, and that's K bottom radius, which itself is the spherical Earth radius that we use by default. So should really be the value that we display here, not this one. So we're doing something incorrect. Okay, and I think I found what it is. The thing is, when we create the planet here, the value that we're using for radius is still the default radius. It's not really the planet effective rendering radius, which is a bit lower. So now, is this a problem? Is this used anywhere? Okay, so we're using the radius here for the construction of the sphere grid. And I'm thinking that indeed for the sphere grid, we probably want to use the sea level radius of the planet as a reference. So yes, we need to keep this radius value. But then it means that when we're returning the sea level, we're just returning this radius directly, assuming it will always be the same as the sea level. And so we don't really need to provide this additional element here. So now trying again to place some trees in the ocean. Oh, I see. It could be that the ocean rendering itself is in fact updating the depth value in this depth texture. So we have a tree placed here, and basically yes, this is really just at the surface of the ocean. So yeah, not quite there yet. You see that those values here were very close to the reference sea level value, so that's not really what I expected. I expected this to be noticeably smaller. If we just have this small difference, then it's going to fail in many cases. Plus you have yeah, probably the waves for the ocean are producing different depth values, so you need to really have a lower bedrock location. So in the ocean rendering shader, we'll see that we're going to retrieve the depth value that we have for the ground from a depth texture. Okay, so we use that to do some computation and figure out if we should actually render the ocean or not. That makes sense. But then this depth value here, we have water depth. Then we are doing this, update the value that we should write back. Why? I think this was done at some point where I needed the final depth value for every pixel to then compute the atmosphere effect for that pixel. But I think this is done already here. Yes, because here when we're computing the surface color for the ocean, we do a lot of stuff, but afterwards we see that we're going to retrieve the sun radiance and sky radiance and the sky radiance to that point. So yes, atmosphere computation is already done for the ocean pixel, so we don't really need the depth information updated afterwards, which means that we could just bypass this statement. So this here is not necessary anymore. Also, let's see if it's actually changing something to the rendering. The shader was updated, but it didn't change anything as far as I can tell. Okay, so this is not making any difference, so we can just comment those lines for the moment. And now let's try again to place the trees. So I'm in the middle of the sea. Okay, and now the value are noticeably lower. Let's go somewhere else with a deep ocean. Okay, not adding anything. Cool. And if we have a partial view, 4 trees. I can't even see them on screen. Where could they be? Oh, that's interesting. Oh yes, I know. That could be because we are on a different cell and I'm not loading the cell. Yes, okay. I was too far away, and the mechanism to load the cell is probably not complete yet. So I need to go back to my original location. Okay, somewhere here, and let's get close to that location and stay here. Okay, let's place some trees. 6 trees, and I see some of them here. 1, 2, 3, 4, 5, 6 trees again. 1, 2, 3, 4, 5, 6. So it seems that we are now properly taking the sea level into consideration, and we can avoid placing trees under that level. And this is it for this time, guys. I do appreciate that this is probably not the most interesting kind of recording, but well, in any case, if you have any question or you want to discuss anything, just let me know in the comments as usual. And meanwhile, I will just get back to writing even more code on my side. So see you next time, and have a nice day. Bye bye.